Hi, welcome back. In this lecture, I want to discuss computer system operation, and I want to discuss a few important concepts, such as the concept of interrupt, multi-programming, and time sharing. So this is a depiction of the typical computer system. So we see many devices, and then we have a shared memory. In a typical computer system configuration, one or more CPUs, one or more cores, and device controllers connected through a common bus that you see here in our figures. So this bus provides an access to the shared memory. So this memory is actually in common with the CPU and device controllers. So the CPU and the device controllers can execute in parallel, computing for the shared resource that is the memory. So how this interaction with the shared memory and how we can handle the request? Well, device controllers inform the CPU that the operation is finished by causing a so-called interrupt. So what is an interrupt? Well, first of all, we might have either hardware or a software interrupt. An hardware might trigger an interrupt at any time by sending a signal to the CPU. So this interrupt is nothing else than a signal to the CPU. Also, a software might trigger an interrupt. So software might trigger an interrupt by executing a special operation called a system call. You might have heard already this word, system call. That is a way to provide an interrupt. So how does actually work when the CPU receives either a hardware or a software interrupt? Well, when the CPU is interrupted, it stops what it's doing and is immediately transferred execution to an address where a server routine for the interrupt is located. So you see here in this plot here the system call service. The CPU resumes the interrupted computation when the interrupt service routine is completed. So when the service routine is completed, then the CPU can continue the interrupted computation. A second important concept I want to discuss in this lecture is the concept of multi-programming or batching system. This actually required for efficiency. So we want to have multi-programming capabilities to provide efficient use of our hardware. Multi-programming organizes the jobs that consist of code and data, so the CPU is always has one to execute. And this is actually needed for efficiency. So the CPU is not idling, but always have jobs to execute. A subset of the total job in the system is kept in memory. And one job is selected and run via a job scheduling. When it has to wait, for instance, for I/O, for instance, the OS switch to another job. So you see here a different execution of different jobs. I want to conclude my lecture talking about the concepts of time sharing that we already discussed briefly in the brief history of operating system. Time sharing, also called multitasking, consists of CPU switching jobs so frequently that user can interact with each job while running. And this creates this idea of interactive computing. Even if you're using one resource, we switch between different jobs, so the user of different jobs have this idea of interacting with the system. So this time sharing provides each user with a small portion of a time share computer. Each user has at least one separate program in memory called a process. We will discuss the concepts of process in the next few lectures. Each process in the time sharing typically executes for only a short time. If several jobs are ready to run at the same time, then we will rely on the concepts of CPU scheduling. So we'll schedule different jobs so the processor can actually execute. If the process does not fit into memory, then we will use additional storage and rely on the concepts of swapping to move in and out from the memory in order to be executed. This is the last slides of this lecture. We'll talk soon.